Okay, so today we're going to start 1.5, and we sort of in the notes on 1.4, I sort of dipped into 1.5 and like hit all the concepts. So 1.4 was not supposed to include the point slope formula or perpendicular or parallel lines, but it just kind of makes sense to me. If you're going to talk about lines, you might as well talk about all of it at once. So today what we're going to do is application problems, and all of these problems we're going to look at today are like test level problems. So actually, as a matter of fact, a lot of them have appeared on former exams. So the good news is I like to kind of knock out the concepts in the last section, so then today when we talk about kind of these test level questions, we've covered all the concepts that you would need to look at these problems. So you'll see domain and range come up. You know, sometimes we might infuse some circles in with lines. So I want to look at a bunch of examples and kind of show you guys a lot of the different ways we can ask you to work with lines with maybe not ever even using the word line or looking at it in a traditional sense. So the first thing I want to look at, right, we'll start with something pretty straightforward, right, is we want to find the slope of a line that passes through 0.47 and is perpendicular to the line x plus 6y plus 4 equals 0. So just like with circles, I said, well, there's multiple ways we can give you the question or give you the equation, right? But if we want to know anything about the equation, we usually want to convert it into its standard form. So this is a line, right? Y is to a power of 1, x is to a power of 1. And we're actually going to take this one step further, and we're also going to find the equation of the new line. So if all I wanted was the slope of the line, right, all I would have to do is grab the first slope and calculate the new slope. But since they gave us a point on the new line, it would make sense to also ask you to find the equation of that line. So before I can write the equation of the new line, right, I have to identify what the slope is of the original line. So the absolutely incorrect way to do this would be to try to look at that equation and try to extract the slope in that form. You just can't really do it. Also, notice there's a number in front of the y, right? So you want to make sure that, you know, probably it means that 6 is going to be in the denominator somewhere, but we want to make sure we're doing it correctly. So let's take the first line we were given. And let's put this in y equals mx plus b form. So we do that by just solving for y. So we're going to leave the 6y on the left. We'll move the x over, the 4 over, and then I mentioned this on Monday, right? When we divide by 6, we want to divide each term by 6, not the whole equation. Okay? And so even though 4, 6 would simplify down into 2/3, we don't really care about that, because all we want to do is extract the slope out of this line. So the slope in line 1, right, is just negative 1/6. I can pull it right out of the line. So what's the slope of a perpendicular line going to be? Positive 6, right? You flip it and multiply by negative 1. So that means M2 on our new line is positive 6. And so that's the first part, right, of the question. Find the slope of the perpendicular line, right? But if I want to write the equation of the line, then I need a point on that line. So now that I have a point on that line that was given in the problem, I can use the point slope formula to find the new equation for, line 2. So we say y minus 7, right, equals our slope of 6 times x minus 4. We're going to distribute the 6. And then I'm going to add 7 to both sides and that should equal negative 17. So once again, you can always check that the new line you've created, the slope in the line in y equals mx plus b form should match the slope that you put in when you set up the problem. So it did come back as a 6, so we're good, yeah.
And so you don't substitute like 7 for y and 4 for x?
So that is a method that they teach in high school that I personally loathe. Because it's fine. That is a valid way of doing it. So like I think the way a lot of you learn in high school is you set up y equals mx plus b, you plug in the 6, then you plug the point in for x and y, solve for b, and then you have to go back and rewrite the equation and plug the b back in. The beauty of the point slope formula is it's just all in one equation. So remember, and all this was, we talked about this on Monday, all this equation is the slope equation where we added the change of x to the other side, right? Remember, we multiplied by both sides. So I'm fine if you do that. It's just you're creating additional steps to the procedure that aren't really necessary, okay? So I've never really gotten a really good answer on why they do that in high school, but that is how everyone learns. I mean, it's just, and I really think since the No Child Left Behind, since they've done more of like a standard curriculum, like I've noticed in the last like 10 years, it just seems like everyone comes out of high school thinking that's like the only way to do it. And it's traditionally, like when I was in high school, we just used the point slope formula. It just made a lot more sense. So it's fine if you do it the other way, as long as you're getting the right answer and you're careful with it. But just know that the more steps you throw into the procedure, the more chances you're giving yourself to make like a mistake. Yeah, but that's okay if you're doing it that way. Is Alex, anybody done anything on Alex? Is it having you plug the point in?
Yeah.
Does it do point slope or?
It does.
That's really strange because the textbook has the point slope form. Okay, well, either way is fine. I just personally like doing the point slope. That's just makes more sense to me to just go directly to the answer. Okay, so that's a pretty straightforward question, all right? So this is even something that could even appear on like, I would even consider this like a basic skills level type question, okay? So one of the things I want to look at now is let's look at a application problem of looking at just one line. And then what we're going to do is we're going to look at how we can write functions where we have multiple lines or multiple pieces of information included in one function. And sometimes we call those piecewise functions. All right. Oh, this pen's going out. Let's use a different color. All right, so I'm going to use a new piece of paper for this one because okay. All right. So, Josh, right, sells burritos from his food truck, right, on weekends. And if, oh, you know what? If you guys have only been doing the homework in 1.4, the textbook doesn't introduce point slope until 1.5. So when you get to the 1.5, 1.6, they may change it up on you and have you start using the point slope formula. That might be the issue. Yeah. All right. So if he prices them at $4.50, right, he usually sells 200 burritos. Right? However, right, oops, for every 25 cents reduction in price, he sells an additional 20 burritos. So we want to do a couple of things. So the first thing we want to do is we want to come up with a line, right, that models sales as a function of price. So the first decision you have to make when you're building a linear model is you have to know what the input variable is versus the output variable. So if it says sales as a function of, remember, function of is telling you what's going to go inside. So price is going to be the input variable, and sales is going to be the output variable. Yeah.
But he just sells one additional burrito, or is it?
Oh, it's just being 20. I said it out loud and then didn't. He sells 20 additional burritos. Yeah, that would make sense. I said it and then didn't write it. Okay, so whatever you're modeling, so another thing to look for in problems when it says we're modeling blank, that's usually the output variable as well. So when we describe the model, we usually describe it by the value that comes out of the model, not by what goes in. But function of is telling you what goes in. So we were actually given a data point, and we were given a slope in this question. The data point says, well, if we know X is price, right? So the first point we were given, well, if the price is $4.50, right, his sales are 200. Then we were told for every reduction of 25 cents, so that means that's our delta X, and you have to know that it's a negative delta X because it said it was reduced or decreasing, okay? He sells 20 additional burritos. So the slope, right, is the change in Y over the change in X. So he sells 20 more burritos, so it's a positive 20 because it was an increase of 20, right, for every decrease of 25 cents. So it's a positive 20 divided by a negative 0.25. So one of the things you need to look for in the question is we're not just going to put positive and negatives in front of the numbers for you. You have to know that when you're talking about slope, it's the change in a quantity. So increases are positive, decreases are negative. Right? Does that make sense? You ready? Okay. So 20 divided by 0.25 is negative 80. Okay. So an additional way we could have given you this problem was by giving you the $4.50 and the 200 burritos, but instead of telling you how the price adjusts, we could have just said, well, when he prices the burritos at, let's say $5, then he would sell 240 burritos. So then in that case, we would have given you two data points, and you would have had to calculate the slope from the two data points rather than us describing the slope in words in the problem. So that would have been another way I could have adjusted it. And if we had done that, you would have still gotten a negative 80 out as your slope. Or sorry, I should have said for every $4, that would have been a reduction. He would sell 240 burritos, right? Because that would be a drop of 50 cents, and then he would sell 40 additional burritos. All right, so once you've identified, right, the point and the slope, and as long as you've got the input and the output in the right place, well, then you just use point slope to find the equation of the line. So in this problem, we would say, well, y minus 200, right, equals negative 80 times x minus 4.5. When I distribute the negative 80, right, I get negative 80x. Negative 80 times positive, or negative 80 times negative 4.5, excuse me, is positive 360. And then I add 200 to both sides. So this equation, right, models sales, right, as a function of price. So price goes in and sales will come out. So this is an example of a question, like I told you the other day. We'll ask you to build the model, and then we will ask you additional things about the model that you just built. So it's very important that you can do the first step properly. So how many, right, will he sell if the price is $6? So Josh is a real guy. This was one of my questions, and he does make burritos, not on a food truck though. He makes burritos at Walker's every morning, so I eat a lot of his breakfast burritos. All right, so if he prices them at $6, well, now that we have our model, right, that's telling us X is 6, right? So we just go to our model and we plug in 6. And we get, 80 burritos. All right. So there's one last part. So if his goal, right, is to sell 420 burritos on a single Saturday, right, then what price should he charge? So this is telling you the sales, right? So we would set the equation of the line equal to 420. So y is 420. So that means 420 equals negative 80x plus 560. And now we just solve the equation for x. And when we solve for x, that will tell us the corresponding price to that sales figure. So we'll subtract 560 from both sides and get negative 140, right, equals negative 80x. And remember, when you divide a negative number by another negative number, you will come out with a positive price. And it turns out if he prices the burritos at $1.75, he'll sell about 420 of them. So notice what's happening as we keep reducing the price, right? We're selling more and more burritos, but we're already down to only $1.75. So eventually there is a floor, right? You can't sell the burritos for negative money, right? Then you would be giving people money to take your burritos, right? There's a zero point. So this is an example. If we wanted to talk about domain and range in this problem, well, if you look at the original equation, right, and we look at our domain and range rules, well, mathematically, lines accept all reals, right? However, in the context of this problem, we would have to say, well, you're not going to give your burritos away for free, right? So we would probably say that the domain starts with 0 not included, right? So we would price it anywhere above 0, right? And then there's also going to be a cap where the price, remember, as he prices it up and up and up, he sells fewer and fewer burritos. So there's actually going to also be a maximum value of this domain, because if you price it too high, then the burritos are going to come out in negative territory. So we can actually see, right, what the domain and range of this equation were. So we can look at it by finding the intercepts of the line, okay? So when x equals 0, right, if you plug 0 into the line, y would come out to be 560. Because you just pop in 0, you'll get 560, right? However, when y is 0 and you solve the equation for x, you get $7. And hopefully you guys can do that algebra, right? Set it equal to 0, solve for x, plug in 0, get 560. So if we wanted to talk about the domain and range of this equation, well, the applied domain, right? Well, I would say, like we said, we're not going to price them at $0, so I wouldn't include 0. So we'll say we'll accept everything down to 0, right? And I would say up to $7, also not included, because if you price it at $7, you sell nothing, right? So there is sort of an argument to be made where you could include 7 or not, but this is one of those situations where if we asked about domain and range in an applied setting, I would give your domain and range and then, maybe jot a sentence down and justify why you did the endpoints the way you did, and that's acceptable. As long as your logic is sound, we'll give you credit. So there is a case to be made for including and not including the 7. But does everybody understand why I said that's the limit, right? So if you go beyond $7, you're in negative burrito territory, right? If you go less than $0, you're infinitely, you're giving them away, right? It doesn't make any sense. So the range, right, are the y values that come out. So once again, if we're not going to include the $0 price point, then we're not going to include 0 burritos. And if you don't include the 7, sorry, if you don't include the 7, then you shouldn't include the 0. If you don't include the 0 here, then we don't include the 560. So this is where the counter argument could be made when you look at the range, right? You could have a bad day and sell no burritos. That could totally happen, right? So if someone wanted to say, well, I actually want to include the 7 in the domain because 7 means you sell 0 burritos, then you would include the 0 corresponding 0 in the range, okay? But that's kind of 6 of one, half a dozen of the other. So it's a judgment call when you do the domain of an applied function, but that's where I would kind of justify my reasoning of why I decided to include or not include the reals. So does everybody see this? So this is an example of where it's not all reals. Yeah.
Can you just say like we're assuming we're going to sell at least one?
Sure, that would be a perfectly good explanation, yep. So it's just some kind of justification, you know, on those endpoints, yeah. Mhm. All right, picked out some good problems today for you guys. All right, so now I want to look at something where rather than just being able to model by one equation, we may have to do kind of a combination of things to set up a model. And this is a scenario that, I don't know, some of you may or may not be familiar with. I know everybody has unlimited plans now. All right, but let's say that your cell phone, right, is $100 for the first 1,000 minutes. Okay? And then it's 10 cents for each additional minute. Okay, so let's say you're not lucky enough to have one of these unlimited plans. And if you really remember, well, you guys don't, you probably weren't born yet. This makes me so sad. When I first got my first cell phone in '97, you just were charged per minute. There was no plan. There was no minutes included. There was no monthly. It was straight up. Here's what you use it, you spend it. All right. So this scenario cannot be modeled in just one line, right? Because we have, what's the slope of the first 1,000 minutes? So remember, the slope is the change. 0. Nothing's changing. It's $100 whether you talk for 10 minutes. It's $100 if you talk for 900 minutes, right? So until you get to 1,000 minutes, the slope is 0, right? It's after you cross the 1,000-minute mark, then you start climbing at 10 cents per minute. So this can actually not be modeled in just one formula. You're actually going to need to break it up into two pieces. So what we do is we kind of call this, this would be an example of a piecewise function. And we're going to get into those a little bit more in depth later. But a piecewise function is literally a function made up of pieces of other functions. So it could be linear for one part of it. It could be quadratic for another part. It could be circular. So what we do is we sort of like chop and then copy and paste together all these different functions. So when you describe a piecewise function in terms of a formula, you have to have intervals for each piece of the function of when that's valid. So if we write down what we're saying here, right? So we want to model, right, price versus minutes. So that's kind of an obvious relationship, right? You would want to plug in how many minutes you talk, and then you'd want to look at your bill coming out. So minutes are going to be the input variable, right? Price is going to be the output variable. And so the first interval would say, well, if you talk 0 minutes a month up to and including 1,000 minutes a month, right, your bill is a flat $100. So that equation, that's just a constant. So that's just a horizontal line, right? So we got a slope of 0. However, if x is greater than 1,000, right, then we're going to have a slope of point, we want to measure in dollars, so it's going to be $0.1, right, per minute. So it's a slope of just 0.1, right? And so in the problem, it doesn't say $10, it said 10 cents. So you also want to make sure the units match up if they give you the value in two different units. So if one was in kilograms and the other was in grams, you need to either put them both in grams or both in kilograms, right? So in this case, we want to have them both in dollars. So if I want to write the equation for what's happening right here, we need to know that, let's say we talk for 1,001 minutes. Okay, so we just talked for 1 extra minute over our plan. So what's the monthly bill going to be in that case? $100.10. Yeah, but yeah. So if you only talk for 1 minute, right, over the plan, right, then you only were charging an additional 10 cents. Okay. And a second point on this line, right, we could come up with a lot of them, right? If we talked for 1,002 minutes, right, the bill would be $100.20. You could also have just used the point, well, at 1,000 minutes, it was just still $100, because that's still true as well. So if we wanted to calculate the slope, right, if we did the change in y, right, over the change in x, if you actually use 2 data points, you would still just see that the slope is a positive, right, 0.1. So if we were to graph this, so here's minutes, here's price, here's $100, and we'll put 1,000 minutes here. We would see, right, that we get a horizontal line up to that value. So anywhere in there, it's a flat $100. But then it starts climbing, right? And this line, and I drew it, it's actually even shallower than that, but just so we can see it, right? We see that the slope is 0.1, and that was what the bill would look like as you talked more on the phone. So if we wanted to generate the equation for this second part, we can simply use the point slope formula. So I'm just going to grab this point right here. We have our slope, and we'll say, well, y minus, right, $100.10 will equal 10 cents times y minus, or excuse me, x times 1,001 minutes. I'm going to distribute the 0.10. Make sure that's right, yep. And then I'm going to add that. So it should just give me, yeah, that. So this line, right, looks like it has a y-intercept of 0. And in fact, if I were to draw this line, right, if I were to dot this line all the way back, it would in fact cross at that 0 mark. That slope would, okay? So one way to express our final function is the following way. Price equals the equation 100 when x is between 0 and 1,000, and it's 0.1x, it should be plus 100. I feel like something mathematically didn't work here. Because you still should be paying that plus the additional $100. Yeah, this should be plus 100. Because, oh, no, it's not. Never mind. The way we've defined this, we're okay. Okay, sorry, my bad. So if the x was measuring additional minutes over 1,000, then let's say you talk 2 additional minutes, then that would come out to be 20 cents. So you would need the 100, right? But because we're actually defining x as total minutes we talked on the phone, so we don't actually need the plus 100. So this is a way we could do it as a piecewise function where x is in total minutes a month that we talked, okay? So does this make sense when you set it up? Now, one thing you've got to be clear on, right, when you're doing these, if you do these intervals, the 1,000 is included here, so you cannot also include it here. Okay, so it's just like we talked about domain the other day when I said it's either in the interval or it's not in the interval. So the reason that you can only have it in one of your intervals is, what if I tell you, if I said something like, tell me the phone bill for someone who talked $1,500 a month, right? So what you would do is you would come over to the intervals and you would figure out, well, which one of these intervals includes 1,500? Well, clearly it's that one, right? So if this is the interval that includes 1,500, then this is the equation you plug 1,500 into. But if I said someone only talked $1,000 a month, well, you would have to plug it into this equation because this is the interval that includes the 1,000. So you can't have it in both intervals because then it's not a function anymore. Because you remember, you would, for every one x, right, you're only supposed to get one y. So there can be no ambiguity about the x values that you plug in. So if you include it in one thing, you include it in the other. Now, mathematically, right, if you plugged 1,000 in here, you would get 100, right? But if you look at the function, that makes sense because these two lines are connected there, right? But technically speaking, when you define the domain, you're only allowed to put it in one of these two places, okay? And it makes more sense in this problem to put it here because we said everything up to and including 1,000 minutes is the $100.
You just solve from there, like on the top one?
Mm-hmm.
You just solve from there?
Yeah, you could just, well, for this one, you don't have to solve anything because you just plug in 100. I mean, it's just $100, right? So if X is 900, your bill's 100, right? If X is 10 minutes a month, your bill's still $100. So that's how those plans with X number of minutes always work, no matter, and now I guess a better analogy for you guys now would be data plans, right? A lot of you guys have data plans that are capped at a certain amount. So if it's 2 gig of data, whether you use all 2 gig or not, you're still paying that flat rate. It's when you go beyond your data plan that they start charging you for additional data usage. All right, so there's another one I want to look at, right? Which, let's combine circles and lines together, because why the hell not? It'd be fun, right? Okay. So we want to find a line tangent to the circle that is centered at the origin with radius 5 and passes through point -3, 4. Okay. So the way that I've worded this problem is a little ambiguous because the word tangent means that the line touches the outside of the circle at exactly one point. So when we talk about a line being tangent to a graph, right, or a line being tangent to any other function, it means the function and the line share only one point value, okay? So, and then it says the circle centered at the origin with radius 5 and passes through the point -3, 4. So what I was getting at here is, right, the line, right, passes through that point. Now, what's going to work out in this problem is that's the point that the line and the circle are tangent at. But if you didn't know that, you would need to check if that point was on the circle. If that point was on the circle and the line also passes through that point, then you know it's tangent. So usually when we give you equations where we say it's tangent to a graph, we'll say at this point, right? But I found this question and it was worded in this way and I thought, well, that's a little weird, right? Because we usually would say it's tangent at that value. So if it didn't say at the value, you would just verify that that was on the circle, but in this case it is. So the circle equation, if you're centered at the origin, right, the center is 0, 0. So x minus h would be x, right? Y minus k would be y. And what do I set this equal to? 25, because it's the radius squared. So there's the circle equation. What we know is this is tangent, right, at 0.34. So this is on the circle and on the line. All right. So let's look at a graph and see what this is going to look like. So here's our circle, right, with radius 5. And point -34 is in this quadrant right here. Okay? And since we know that point's on the circle and the line, right, it's probably somewhere about there. Okay? So the line is going to look like this. And I want to find the equation of that line. Now, we don't know anything about the slope. They didn't say anything in the problem about the slope. However, if you kind of have a little bit of a fundamental understanding of geometry and how circles work, we actually do know what the slope is, okay? So can anyone tell me what the relationship between a radius on a circle and the outer part of the circle is? It's always 90 degrees. It's perpendicular. So by definition, right, if you draw any radii out at any one of them, out from the center of the circle to the edge, the radius, right, is perpendicular to the tangent, to the point that's on that edge of that circle. So that means right here, if I were to draw, right, a line back here, that is perpendicular to that. So we can actually figure out what the slope of the dotted line is. And if we know our straight line is perpendicular to that dotted line, well, then now we can extract the slope. So this is really easy to find the slope of the dotted line. One point is 3, 4, and the other point is the origin. So if we look at the change in y over the change in x, we'll get 4 minus 0, right, over negative 3 minus 0. So that works out to be negative 4/3. That just took from there to there. Right? And so, for those of you looking confused, that was the other point that I found on the dotted line, right? So if we know the straight line is perpendicular to the dotted line, well, then the slope of our straight line, right, or in this case, our tangent line should be what? Positive 3/4. We also know that negative 3, 4 is on that line as well. So now we have the slope of the line, and we have a point on the line, and now we can write the equation of the line. Notice that it becomes x plus 3 because it's a minus minus 3. So I don't want to do fractions, so I'm going to use my little algebra hack. And I'm going to say 4y minus 16, right, equals 3x plus 9. So remember, this 4 cancels this 4. And then I'll say 4y equals 3x, 9 plus 16 is 25. And then we divide everything by 4. And so once again, you can always check yourself. The slope that comes out of the line should match the slope you put into the line if you're doing that algebra step. All right, so I have one more that I want to look at. Let me find it. It was a good test question. Ah, yeah. Alright, so I have one that appeared on an exam last semester. All right. This will be the last one we do. So the energy cost for a building increase at a rate of $80 per hour from 8 a.m. to 6 p.m. From 6 p.m. to midnight, they increase at $45 per hour. Right? And suppose we know that at 8 a.m. the total cost is $300, and we want to find a model, oops, that's an L, right, that explains the costs from 8 a.m. to midnight. So we kind of looked at something like this when we looked at the application problem we did the other day about the factory producing stuff. Except in that problem, we didn't give you, we had two distinct separate factories, right? But this is one building. So what we're going to have to do is, this is kind of like the cell phone problem, where we're going to have to split this up into what's going on from 8 to 6 versus what's going on from 6 to midnight. So costs are going to be the Y value. Right? And time is going to be the X value. So most likely what we would do here is we wouldn't actually plug the time of day into the equation. So what we'll do is we'll let X equals 0 represent 8 a.m., right? So then what would 6 p.m. be? That's dollars, but I mean, what would the X value for 6 p.m. be? 10. Right, that's 10 hours later, okay? And then what would the X value be for midnight? 16. Yeah, that's right, 6 more hours, okay? So at 8 a.m., right, the cost is $300, and we know the slope is a positive $80, right? But we don't know a point value here yet, but we know from 6 p.m. to midnight, right, the slope changes to $45. So let's look at modeling 8 a.m. to 6 p.m. first, because that's a little bit easier to do. So from t, right, equaling 0, up to t equaling 10. So that's 8 a.m. to 6 p.m., the first 10 hours of the day, right? We know that at 0, right, the cost was $300, and we know the slope was 80, so we can simply use the point slope formula to get the equation of that line. Now, they did not give us a second data point for what's happening at 6 p.m. So this is one of those situations where if I had this problem on an exam, I would kind of treat it like the cell phone bill, where I wouldn't say that there's maybe a jump in the cost without giving anything else. I'd say, well, I'm going to assume this is a continuous function. So I might make a note on there, well, assuming a continuous function, or like assuming, something like that. So let's look at what happens in our line when x equals, and this should be an x, guys, when x equals 10. So if I simply plug 10 into this line, right? Well, 80 times 10 is 800 plus 300, so the bill is $1,100 at 6 p.m. All right, so then that will become, right, 10, 1,100 will become the data point that I use to then apply my new slope. So from x is 10 to 16, sorry, we're not going to include the 10 here, right, from 10 to 16, I have a data point of 10, 1,100 and a slope of 45. So now I'll write the new equation. So y minus 1,100 will equal 45 times x minus 10. So y minus 1,100 is 45x minus 450. And what's 1,100 minus 450? Some of you guys can do that in your head. I can't. All right, let's see if you're right. And you are, 650. Okay? So if we want to write the final model, here's what it's going to look like. The cost, right, says, well, for the first 10 hours, it's 80x plus 300, and that is when x is between 0 and 10. The second line is 45x plus 650, and that is from hour 10 to hour 16. So just like with the cell phone problem, if we plotted these 2 points, these graphs, we would see they intersect at the 10th hour, and so you would get a line with a pretty steep slope. So you would have something like this. You would have a line of slope 80, right, till hour 10, and this should be at 1,100, and then you would have a shallower slope, right, up to 16. So this has a slope of 80, right, this has a slope of 45. So that's what the graph of the function we just looked like worked. Yeah. All right, so we'll call it there.